Okay, the following is a video over section 3.4, which is called Derivatives as Rates of Change. And this is the application of derivatives that is quite often used in physics. So if you're in physics, this should look very familiar to you. We've gone over this example before, but I want to go over it with you in detail again before we start this. I will come back to this example over and over again because I can use this example to explain everything in motion, and I can use it to explain everything once we get to chapter 4 and beyond. So anything that involves motion, using position, velocities, accelerations, I can use this example. So the example I've given you is the example of an object being thrown into the air and falling to the ground. And we have three equations here. The first equation is this one right here. Negative 4.9 x squared plus 10x plus 5. So what this means is that you throw an object in the air standing at 5 feet and with an initial velocity of 10 meters per second. Okay, and so you can see that here, this equation is y sub 1 right here, and this shows a parabola where the object goes up and it finds a maximum height and then it begins to fall to the ground and hits the ground right about there. Okay. But we all know that. We've been doing that since Algebra 2. We're familiar with this problem. Now let's bring in the calculus aspect of this. The thing with calculus is that we want to calculate the slope of a tangent line. Now what I want to do is calculate the slope of a line here. And what I'm going to do is I'm going to come in here and I'm going to draw a line to the best of my ability, going across, and then I just want to show the slope of this line basically. And so if I were to show the slope of that line, let's have my y-axis here. I want to do the pen, not the line. I want to show my y-axis here. My y-axis represents height. Okay, and my x-axis represents time. Okay, so if I were to take the change in y and divide that by change in x and calculate the slope, then I'm going to get my height, which is in meters, being divided by time in seconds. Okay, so when I take the change in y and I divide it by the change in x, I'm going to get meters per second. Okay, now that's all fine and good, but here's the thing: is when we have when we take our derivative, remember our derivative is a function that generates the slope of the tangent line at any point. And if I take the derivative of this position graph, okay, if I take the derivative of that position graph, then I'm going to get my velocity graph. Velocity. Okay, and so the velocity is the derivative of my position. Okay, now this has a y-axis of meters per second, okay, and my x-axis is still in time. Okay? Now, if I were to calculate the slope of this and take the change in y over the change in x, then the change in y over the change in x is equal to meters per second, which comes out to be meters per second squared. Okay? This is acceleration. Okay? Acceleration is the derivative of my velocity. So we have all this stuff going on here, and you've seen this before, but I just want to clarify that we start out our initial function. When you just see an f of x, that really just represents the position. Okay? When you see an f prime of x, that represents our velocity. When you see an acceleration, then you get f double prime. You have the second derivative. Okay, so that's an important thing to note, that when you're given just a regular function, you can assume that's position. When you're given f prime, that's a velocity function. That's a rate. Okay, and then acceleration is the second derivative. So there's a lot of stuff going on right here. There's a lot of important stuff, but what I wanted you to see how all these graphs are really related to each other. Okay, now I can come in here and I can say, let me erase some of this stuff. But let's just take a look and see exactly what's happening here. This is a very, again, I'm going to use this over and over again to talk about calculus. So I will always come back to this. It's a very, very important example. So it's something that you will know by the end, and hopefully you will be using this on your AP exam to help you answer all those questions. So let's first start talking about our first graph here. Okay. Now, if I come in here and I show, let me change my color to red. If I come in here and show the path of this object going up and then coming down, we've done that before, but let's take a look here. Now, if I were to take the slope at this point here, okay, right here, my initial velocity is at 10, okay? And as the object gets thrown into the air, we want to think about what happens to each of those individual slopes. Okay, and what happens to those slopes as time goes on, as it reaches a maximum? Well, what happens is those slopes slow down. Okay, the velocity is decreasing. Okay, and the velocity is getting to a point where it's zero, right when we have a maximum. And you can think about that. When you throw an object in the air, what does the object do? So right up here, it is slowing down. So right there, it is slowing down. Okay? But it's still going up. So slowing down, but it's going up. So the interesting thing here is that you can see that the velocity right here is positive. It's above the x-axis. So that means that the object is going up. Okay, then all of a sudden, what happens when the object stops in midair and it starts to go down? And that's what's happening right here. All these points, the object is going down. All those points, it's going down, down, down. And what happens to that object? It starts to get faster. Now, the slopes of all these points are all negative slopes. And those points are then plotted down here. Now, let's think about it. Here, what's the object doing as it's going down? It's speeding back up. It's speeding up. But it's going down. Don't want to misspell going. Going down. All right. So as it's going down, that's why my velocity is negative. So velocity, let's kind of define what velocity is. Velocity is it's a rate at which an object travels. So rate at which an object travels but it has direction. Okay, it can go up or down, right or left, all of this stuff. Okay, now let's think about this. Okay, this is all due to what? When I throw an object up in the air and it hits a maximum point and it starts to fall, what is causing that to happen? And this number should look very, if you're in physics, this number should look very familiar to you, because that number is represented as acceleration due to gravity. Acceleration due to gravity. Okay, and that's at negative 9.8 meters per second squared. Okay, so I want you to notice something here, that my acceleration is negative. Now, we know that the object was slowing down, okay, over, as it right here as it was going up, and then it was speeding back up, okay, as it was going down. Now, let's take a look at something here. Let's go in here and let's draw I'm going to draw a little line right here that goes from this maximum height all the way down. That was terrible. Going from this maximum height all the way down. Okay. Now I want you to notice that at this point right here, on the velocity function, okay, the velocity is 0 right here. The velocity is 0. Okay, and the velocity changes directions. Okay, but if I look over here, it's slowing down. Okay, right here, it's slowing down. My velocity is positive, and it's moving towards the x-axis, but my velocity is negative. I have a negative force acting on something that's going up. So something that's being pushed down as that object's going up. I mean, the reason why the ball is slowing down is because you've got gravity that's pushing down on it as it's going up. And then it hits a maximum height, and then it begins to go down, and the velocity starts to get bigger. Okay, and that's because the velocity is negative and the acceleration is negative. They're both going down. You have the same force, the force of gravity is acting on that object to go down, and so it's speeding up. Okay, so all of these things, I'm going through a lot here, but the reality is that I can really show everything using this very, very simple example. Okay, and remember that this is my position, this is my velocity, and this is my acceleration. This is my function f, this is my function f prime, and this is my function f double prime. So if you're given a function, you're given an f, and it asks you a question about the velocity, and all it gives you is f, well, you know how to take derivatives. So you can take the derivative and figure out what's happening. You can tell whether it's slowing, or whether it's the velocity is the object is moving up, or if it's moving down, and then you know all of the acceleration at those points. Okay, so that really concludes the video for this example. As far as what's happening, it's just kind of a concept. I'm going to use this all the time. Okay, so hopefully you enjoyed this video, and this should help you answer all of the questions pretty much for the first semester. So keep looking back at this.